and so on, right?
In the brain, so it does make sense, to see that also as a transformation. But in terms of relating or predicting one similarity structure from another, there's indeed more maybe to do in terms of formalizing that, right? Going beyond correlations between two structures. That's quite interesting.
I see. By the way, now we are on YouTube formally.
All right.
I think it should be started. Yeah, it started.
Correlations between two.
All right.
So Marike, so how can we go beyond just the correlation between the two structures?
Yeah, so, well, one thing that, of course, we could do, so we have been doing a bit of, which is more like, modeling, which is more of a regression approach, I would say, where you would have the models, but that consists of multiple components. So you could have similarity based on shape and similarity based on color, and then you can weight them to explain, for example, the brain representation or the judgments or perceived similarity. That we've done, but it's not really saying, basically, can we apply a transformation from one representation to the other? And that is quite interesting too, I think. What we have done is looking at pattern transformations in the brain. So where we would have response patterns and then ask, in a next region, can we actually get can we predict the response pattern there? So that's one way of looking at transformations, which you could possibly also apply at the level of the similarities, right? If you look at data, of course, there's always noise. This makes it a little harder because if you think about these pattern transformations, there it's quite interesting to think about whether this transformation is sparse, or whether it's actually not sparse, but when there's noise in the data, that becomes harder to judge, and you need to do some simulations where you make some assumptions and then compare that to your actual data, right? So it's somewhat tricky, but these types of methods where you just have a transformation matrix could be interesting because you can investigate the transformation matrix. And then usually, in terms of computing the transformation, we just use methods regression-based, so bridge regression, for example, or that works. But it's quite, it's challenging to infer interesting components from that transformation.
Do you do any kind of manipulation, like in terms of either perceptual similarity or brain activity or structure itself, and then how they get kind of affected to each other? Like the task instruction that you mentioned today was one of the things, right? If the task
I think these are that's the what I've done is changing the task. And they're, I think they're the most important thing that I can say is that if you do these manipulations with the task, that for the visual structure or the visual representation in visual cortex, it doesn't have a huge effect for isolated object stimuli.
Right.
But if you start to have attention involved and there's multiple stimuli, where now you can manipulate which one you attend to, then you start to see some larger effects on the representation. But these are these, I would say that's what I've tried. Of course, you can think about more, let's say, direct interference. You could think about performing, it's not so easy in humans, of course, but then that would also be interesting, right? If it would be possible to, for example, virtually lesion at a particular part of the system to see what happens to representations further downstream, for example. But yeah, and of course, people have been using TMS, but yeah, how we still don't completely understand how that works, right? So it's yeah, but that I could imagine in principle is also a good approach if you want to get a better understanding of the parts of the visual system contributing to your perceptual experience. Yeah.
Yeah. Masami, and you think that now we are kind of at the stage where we can probably start computing the Korea structure for information structure for based on fMRI activity, or do we still need lots more advancement in terms of algorithm or the amount of data?
I mean, Korea structure is quantified by
the information structure, yeah.
Information structure.
From let's say B4 area B4 or area IT.
I mean, information structure proposed in integrated information theory is basically really hard to compute if you want to exactly compute, but some approximated version can be possible. First, I think that we just use the usual, representation similarity analysis, which is just a linear transformation, and then we can use the idea of causal structure thing proposed in IIT. So we can start testing.
Right. Yeah. So today, what Makiko showed, in the beginning, at least using B4's activity state itself, activity pattern doesn't seem to look like Korea structure. So if we can already improve that kind of matching, incorporating the sort of the dynamics, like Hayato said, even if we don't go into sort of IIT fully, just using sort of temporal information of the pattern is already kind of going beyond the usual RSA, right?
Yeah. I think so, yeah. Incorporating some temporal aspects could be some improvement.
Like each of the box.
Yeah, that also. Sorry.
Go ahead.
Well, I was just going to mention that indeed relates also to these ideas of transformations, capturing those. That is, I think, indeed useful. And with fMRI, there's, of course, there are limitations in terms of its temporal resolution. Maybe with coming up with some designs where you could have slowly changing things in the stimulus, maybe that could work. Or pushing the resolution also temporarily. There's certainly some recent studies trying to get data with higher resolution, maybe sampling rates of 4 hertz is sort of the max, I think. So then you could potentially detect some signal up to 2 hertz. Yeah.
I think we should use some model for I mean, just for reconciling this deficit of functional MRI data. But as for color perception, I think that the usual deep learning model, I think, cannot fully explain the neural responses, neural color responses.
Why you think so?
Because that people I think that the people compute how similar the neural activity and the model activity. but I think that for colors, this
Mm.
similarity is not that large. For color responses, I think the similarity is not large. So
What do you mean?
I mean just you know, just if you do the usual object classification learning
Uh-huh.
in the basic deep learning method,
Mm.
then color responses cannot be similar with actual neural responses in the brain. So I think probably that the different learning algorithm is used in the brain.
Mm.
Yeah, I don't know much about how model responses and neural responses are similar in terms of color.
Yeah. Usually well, most studies focus indeed on objects that are often colored pictures, but then when they compare the representation of these images in the brain and the models, then it's usually just focused on the overall match, which could be driven by multiple things, of course.
Yes.
But there may be studies with color. I'm not sure. And it's interesting there to think about very much like was the network constrained when it was learning, in terms of its, let's say, visual diet and also the learning objectives. And I can imagine that if they're not so similar between humans and the networks, then it may not match as well, right? If you just focus on color. But I think it depends very much on that, because the task and the visual input really constrain what is learned, and that of course also holds for humans. And we have multiple learning objectives that our visual system needs to, let's say, satisfy, I think, or actually, accomplish. And of course, we don't know. We have some ideas about what these may be, but the perception of color partly could be related to the goal of categorizing, which is of course the first one people landed on. Like, okay, that's important for the visual system. And then if imagine it's that the representation of color is driven just by that learning goal, then it should be somewhat similar, right, between humans and neural networks in terms of how colors are presented. But it may not be a case that that's the only thing. That seems a bit maybe too simple. So I can completely imagine that there's other aspects, right? Also, if you think about color constancy, or color is quite complex in terms of how we perceive it and how it's also represented, I think. And I would imagine that at the moment these neural networks may not be so close to color perception, because there is more than categorization, I think, that drives how we perceive colors. But I don't know about specific research into color perception with neural networks.
I don't know neither, but what I remember is that people compare the activity in layers, different layers with visual hierarchy, V1, V1, V3, V4, and V4's responses cannot be simulated by the model. I mean, the match is least, I think, between V4 and the model responses not similar. But for example, IT is very sort of similar. If
intermediate
responses are sort of really similar between the model and the actual neural responses.
Relatively similar. Yeah, that's true. Of course, there's still also unexplained variance in IT as well. But it's true that in the mid-level areas, that's the hardest areas, I think, to simulate. And the neural networks do a better job than previous models. But that is true. That there's still, that's the part that's hardest to model. So V1 and then IT, because V1 is really indeed more, we know we can model it quite well by having these Gabor filters.
Exactly.
And at IT, they're very close to the category readout. So then that works if we put that as a learning object. But it's true that in the middle, it's actually in some ways one of the most interesting aspects, maybe.
Yes,
right? How do we actually get there? And then there's, of course, some research also. Though, of course, quite a lot of research in primate studies, right? And looking at V4, trying to figure out what's being computed there. Is it these surface 3D surface elements, or is it something else? And how do we actually get there? And I think that is certainly very interesting. And in deep neural networks, I think if they're trained in a standard way, which is supervised training on categorization, then there's lots of studies now, also from Matthias Fletcher's group and others, showing that there's quite some differences. And there is, for example, this over-reliance on texture, and not so much shape. In neural networks trained that way, it's just a good shortcut, If you can learn the category by latching onto the texture, then why not, right? And I think that then you can start to see that there's quite some differences, because humans have to do, of course, many other things when they're in the world, exploring it and recognizing objects, that if you just train with a static image and say this is this category, it works remarkably well, right? But it's of course missing components that we as humans do experience, and that shape our learning. And of course, we're not there in terms of modeling this very well, right? But
I see.
But there's only been about a decade, not even now, with research looking, trying to improve these neural networks as models of the brain, and of course, changing these different aspects of the networks, including the architecture, for example, including recurrence, changing the way the networks learn. So it's not just supervised, but also self-supervised. Maybe at some point reinforcement learning, which is already much more common in some other areas. Lots of things to work on, but there is progress with these. And I would expect that there may be, there's going to be models that get better and better at explaining also mid-level vision.
Is that what you are kind of currently planning to do next, or what's the sort of the next immediate kind of target of the research?
So what I'm interested in is to understand the effects of the learning objectives. So during learning, how does it change the representation if it's supervised versus unsupervised or self-supervised learning? Do we see that we get a better match with human object representations, for example, both in terms of perception, but also the brain activity when we train with these unsupervised learning objectives? So that's quite interesting. But there's multiple aspects to improve at the same time. And you start to also then think about maybe the input should be richer. Then one should start to think about that maybe then movies. And now you need to start about the architecture, start to think about that, because now we want the networks to be able to process movies. So they're a bit related, these different components. And of course, you can focus on one of them, but usually this may also mean that you have to change something else. But in general, the push is really to make the learning more biologically possible. So you can also start thinking about networks that actually can learn more by themselves. So imagine that a network could actually decide to say, I want to see a different viewpoint now, because then I can learn better what this object is. And that would be very interesting to become and make the networks more interactive with their environment. And maybe you wouldn't be maybe at the stage of having a robot or something, right? Where
I
that
see.
can actually an agent in an environment that can explore it. But maybe you can start to do something with that, where the network gets a little bit of opportunity to learn by itself. But that, of course, requires quite a few changes. But I do think that makes sense, because when we learn, we interact with our environments. And even if we're not so much able to move yet as kids, the things, we see the world, the things move, right?
Right.
And I think, and then we start to interact with the world. So that is quite interesting to start incorporating that to see if that improves
I see.
the models.
I see. So that kind of also relates to your also interest, right, Masafumi? Like incorporating the development aspect, and also what Marika said is may not be directly your interest, but there is also push of this active inference in the predictive coding. That's basically what you are also saying, right? Like you know, giving some kind of agent to have an ability to explore the world, to test their hypothesis more efficiently.
Yeah, exactly. And I think that's an important direction. And I'm sure we'll see much more research in that direction in the near future. Yeah.
So that would probably already then implies the sort of collaboration with the robotics or kind of drone industry or whatever. Is that what you're also thinking, kind of?
Robotics, I think so. I mean, in the I don't know, I don't have that, but I could completely imagine that is going to be quite fruitful to do at some point. I mean, initially, I think we'll just do it in a way where we don't necessarily have an agent, but we can start to make things more interactive. But eventually, I think that will be quite useful. And whether that would be an actual robot or it would be something that's implemented in a virtual environment, which there are initiatives for developing that, and I think that's going to happen. Those are good directions.
All right. If it does explain how our brain is kind of operating right now, and also how we experience the world, then it does sound like a good direction to include also for our future project, right, Masafumi? I mean, in the previous version, we kind of always thought about collaborating with the robotics kind of people, but it was difficult at that time. Now maybe the time is right.
It's getting closer a bit, I think.
I see. That's true.
All right. Maybe we kept you too long. Thanks a lot, Marika. But it was great to hear your also personal goals in the near future and so on.
Great. So indeed, thanks for the nice, for me, evening and session. That was very nice. And I hope we see each other again sometime in the not too distant future.
Great. All right.
Thank you.
See you.
Have a good day.
Bye-bye.
Bye.
Bye-bye. どうしようか。もうそろそろじゃあもうやめるか。
やめてもいいけど。
なんか他に特に言いたかったことある？
まあ個人的にというか、最後の土屋さんの2つ目の何でしたっけ？
マッシブリポート？
局所的なのをレポートできるみたいなののあれの意義じゃないですけど、その辺がちょっとよく分からなかったんですけど。
意義って言われるとちょっとあれだから俺の中ではさ、あれは結構 IAT が言ってるさ、コンポジションとかさ、あとエクスクルージョンとかさ、あとリレーションとかあとインテグレーションもインフォメーションも全部入ってるけどさ、なんつうの普通のビジョンのモデルとかさ、例えばローフリーケンシーのさ、周りも言ってたけど、フィルターがあってさ、 それでそれぞれの場所でこうガバパッチのフィルターのレスポンスがあってさ、
はいはいはい。
でなんかオブジェクトとかカテゴリーとかそういうのはなんかそういうのをこう集めて最終的になんか上の方でこうボトルネックがあってそこからレスポンスが出てくるみたいな話じゃん。それじゃあさ、ああはならないでしょうと思うわけよ。なんつうの、
単純なサリエンスのモデルとかでは説明できないみたいなことですか？
だから何がレポートされやすいかみたいな意味で言ったら、セイリエンシーのモデルとかで、プラスなんか文字の時だけトップレフトから見るとかさ、そういうなんかアドホックななんかメカニズムとかつければいけんのかもしれないけど、例えばなんか、なんかエッフェル塔が見えたってリポートするっていう、そのレベルのローカルな話ってさ、ローカルというかスペシフィックな話って、まあ別にディープラーニングで全部できるよと思うって感じ？
いやまあやりようによっては単にその認識みたいな話で言えばいくらでもできるんじゃないですか。わかんないですけど、
まああれ
人間でやるっていうのはそれはあれだけ早くできるとすごいねとかそういう話ならですかね。なんかどのあたりにそのなんか驚きじゃないですけどそういうのがあるのかなっていう。
まあだから人間のサイコロジーを知ってて、基本なんかみんなグローバルでコアスなものしか最初は見えてないみたいなことを考えてる人からすると、あそこまでなんかそのローカルなものとかディテールが、ディテールでしかもスペシフィックなことはリポートできるっていうのは俺はかなり驚きなんじゃないかなと思うけどね。
なるほど、そういう文脈でってことですか。
やっぱカラーの時みたいになんかそう単純にはこう驚きが感じられないって感じ？
いやというかまあクオリアストラクチャーとかそういう話の時にそれがどういうふうに効いてくるのかとか、なんかその辺が、
そういうことか。で俺もねそれはねいろいろ考えることあるんだけど、例えばなんかそのさ、そのやっぱシミュラリティストラクチャーにしろプロジェクトにしろこれにしろさ、やっぱなんかコンセプトってさ、コンセプトって概念という意味のコンセプトの方だけどさ、なんか絶対影響を与えてるわけじゃん、見えに。
そうですね。
何らかの。
与えてるでしょうね。
マリエ系のさやつとかってさ、カテゴリーの、モデルでやったらさ、一番なんか、ヒューマンパーセプションのジャッジメントは説明できたみたいな話でさ。
だからヒューマンがカテゴリーベースでなんかジャッジしてるってことですよねってことですかね。
で、だからアピアレンスを、に特化してこうリポートするっていうふうに考えない限りさ、ていうかそういうインストラクションがない限り、みんなやっぱ基本なんかコンセプトを元になんかリポートしちゃうと思うわけよ、シミュラリティって。
まああと土屋さんがやってるそのマッシブレポートだったらまさにそうですよね。だって言語で答えさせてるっていうことは、まさにカテゴリーで答えさせてるってことに相当するじゃないですか、ある種。
まあそうだけど、でもレッドとかブルーとか答えてもいいし、そういうふうに答えるようなイメージもあるんだよ、ゴールドとか。
だからレッドとかブルーってだからカテゴリー。
それもカテゴリーだけどね。だからあれはマッシブリポートのフリーリポートバージョンパラダイムなわけよ。で、あれでこう収穫したワードを使ってパッて見せた時にこのワードはあれに合致しますかっていうのはネクストステップのワードバージョンみたいな話で、
なるほど。
でさらに次のステップがてかまあインパラレルにキャンシェンとかやってるさ、イメージパッチでこのイメージパッチが入ってましたかみたいなことを聞くっていうタイプのやつもやってるじゃん。
ありますね。
あっちに行くとよりそのコンセプトの影響がないようなものを聞くっていう風な話になると思うんだけど、
なるほどね。
でもその時になんかオブジェクトのカテゴリーとかそういうのがなんかどれぐらいなんつうのその関係するのかみたいなのとかもそのうちやっていかなきゃいけないと思うんだけどね。
なるほど。そうっすね。
だからまあ、
うん、
これだ、あれだけ
ゃ、
じゃ話は
まあそうです。
閉じないよ。
なんか結構組み合わせですよね、結局。
うん
だからなんかマッシブ、なんか5個のワードとかで、とか、まあもっとたくさんのワードでの集合的に考えられるものとして、その全体のクオリアを定量化するっていう話なんですよね。
そうだからシミラリティって意味で言ったらさ、ワードのパターンみたいのでさ、
うん、
あるイメージとあるイメージの間のシミラリティとかも多分定義できると思うんだよ。
そうですよね。
ナチュラルシーン同士の。
え
そういうふうにやったら、400個のイメージの間のシミラリティマトリックスがかけて、
え
で、それからストラクチャーをこう、エクストラクトして、それに対応するようななんかブレインエリアというかエクストラクションのやり方っていうのは多分なんかコンセプトを元にしてるから多分ハイレベルエリアを元になる、なんかコリレーションが高くなるとかさ、
うん、
プリフロンタルと
そう
か
ですね。
行けば行くほど。
うん、
一方でそのイメージベースとのパッチでさ、なんかコンフュージョンが起きるとか起きないとかそういうタスクやった時に、
うん。
そういう意味でのなんかこのイメージとこのイメージが似てるというやつをやると、
はいはいはいはい。
多分なんかアーリービジュアルエリア同士でのなんかシミラリティとかっていうのがなんかコリレートするとそういう風になるんじゃないかなっていう気がするけどね。
なるほど。まあ、わかりました、なんとなく。はい。
うん。
だけど、結局、なんか、それが一つ驚きだったけど、まあ、最終的にはそれも含めて、なんか、そのワードのパターンみたいなので、クオリアストラクチャーをなんか定量化しますっていうところに向かってるってことですよね。
まあ、だからそのコンセプトでもやっぱリレーションの一つじゃんか。
うん、だからリレーションの一つとして。
うん。
うん。いや、今日のはだからなんかそういうことが普通にサイコフィジクス的になんか驚きなこととしてなんか分かったっていうところで終わってたような気がしたんで、
まあそうね。
その先がどうなんだろう。
どうつなげるかみたいなのは
そう、そこが気になった。
言えてないかもしれない。
はい。それだけ。
じゃあまあそんなところで今日はじゃあ終わりにしようか。
はい。はい、どうもありがとうございます。
どうもありがとうございました。はい、どうも。
はい。はい。